Hello students, in the previous class we have already discussed if inductor is connected across an AC source, if inductor is connected to an AC source of V naught sin omega t, the resulting current will be I naught sin omega t minus pi by 2, where I naught is equal to V naught by XL, where XL is inductive reactance, that is omega L. Okay. One more thing, current lags behind voltage by 90 degree or pi by 2. In this class we shall discuss power dissipated by the inductor. So what is power dissipated? That is instantaneous power, Pi. That means power dissipated by inductor at any particular instant. It will be simply V into I, V into I, that is instantaneous voltage into instantaneous current. V is V naught sin omega t, I is I naught sin omega t minus pi by 2. This is equal to V naught I naught sin omega t minus pi by 2 is nothing but minus cos omega t, minus cos omega t. If you multiply 2 here and divide it 2, so first I will write minus V naught I naught by 2. 2 sin omega t cos omega t is nothing but sin 2 omega t. So this is instantaneous power at any particular instant. This is the power dissipated by the circuit, by the inductor. Now what is the average value? Average value, P average is equal to Pi bar. This is equal to, no need to go for the calculation or the integration, because this is a particular sinusoidal function, and I have already told you in the previous class that if you go for integration of a sinusoidal function through one complete time period, then the result will be 0. Then the power dissipated by inductor will be 0. Okay. Now this is theoretical calculation. Now we shall study how actually, that means question is, we are applying voltage, current is also, we are getting current, still power dissipated by the inductor is 0. How come this is possible? How is it possible that inductor is not dissipating any power? Okay. So we can understand it if we go for the waveform. Okay. So let us go for the waveform structure. What was the waveform structure? Now first I will go for the waveform of voltage. Okay, our voltage was V naught sin omega t. So how to draw it? Like this. Okay, now up to this point it is one complete time period. Now this is omega t axis. Okay, now this is amplitude. Now this value is V naught. Now how to draw I? I is I was I naught sine omega t minus pi by 2. Sine theta but late by 90 degree. That means pi by 2 phase shift to the right. So if you go for pi by 2 phase shift to right, that means this is the point pi by 2. So I will start from here. That means current will start from here. So if you go like this, current will be like this. Okay. Now if you go back, its amplitude. Okay. Now this is my minus I naught. This is current amplitude. It is in negative axis, that's why minus I naught. And this is plus I naught. This point is pi by 2. This is pi. Okay. This is 3 pi by 2. This is 2 pi. Now this is 0. Now for every now with this waveform we shall also go for the power waveform also. Look here, power is minus V naught I naught by 2 sine 2 omega t. So how to draw it? Look, it is a sine wave. It is a sine wave, no problem. But here the frequency is double, 2 times. That means omega becomes 2 omega. That means within one wave of voltage or current, there will be 2 waves of power. Try to understand. This is omega. That means frequency is omega, both for current and voltage as well. This is omega, this is omega. But look here, for power, this is 2 omega. That means frequency is double. Frequency double means time period is half. That means whatever time period both voltage and current are having, the power time period will be just half of that. That means power time period will be this much. That means power's one wave will be accommodated within this range and another wave will be accommodated within this range. Okay. That means within this range there will be 2 waves of power. So how to draw it? Now look here, this is sinusoidal wave. But if you go like this, it will be positive sine wave. But here it is negative. That means just reverse it. That means I will go like this. But I have to take care that I have to draw one wave within this range. Okay. So how to draw it? It will be somehow. Okay, like this. Then I will go for another wave. Okay, this is the complete wave of power. Now this is obviously the amplitude of power, that is V naught I naught by 2. So V naught I naught by 2. Okay, now the waveform is complete. Now we shall try to understand how this average power is becoming 0. Of course, now look here. First consider this quarter wave. Okay, here voltage is positive, current is negative, voltage into current is negative, so power is negative, because voltage into current is power, product is power. So voltage is positive, current is negative, so product is negative. That's why negative power up to pi by 2. What is negative power meaning? We are deriving for power dissipated by inductor. That means this is power dissipation expression. Okay. Power dissipated means if this expression is positive, then some power is being consumed by inductor. But if this is negative, what does it mean? Negative means it supplies power. If positive power is dissipation, then negative power is of course supply of power. That means from 0 to pi by 2, inductor supplies power to the circuit. Then from pi by 2 to pi, you see here, this is positive, voltage is positive, current is positive, positive into positive, positive, so power is positive. That means positive power means here dissipation. That means inductor is dissipating power, consuming power. That means you can easily say this value is equal to this value. So within one half cycle of power or one quarter cycle of overall, it supplies power, and in the next quarter cycle it consumes power. Whatever power it supplies, again it consumes that. Then we shall see, we shall go for the next quarter cycle. You see here, again voltage is positive, current is negative, so product is negative, so power is negative. That means again it is supplying power to the circuit. In the next quarter cycle, voltage, current both are negative. That means power is positive, negative, negative, positive. So again it is dissipating. So this is supply. This is also supply. Both these are supply. This one and this one and are dissipation. That means at the end of one time period, inductor is 2 times supplying power to the circuit and 2 times dissipating the power. The same amount it is dissipating and the same amount it is supplying. So at the end of one time period, total dissipation is 0 or total supply is also 0. Total dissipation is equal to total supply, net is 0. So at the end of one time period, neither the inductor supplies power to the circuit nor it consumes any power from the circuit. That's all. That's why average power over one cycle is 0. Okay. So this is all about power consumed by inductor. Okay. In the next class we shall discuss, I think, capacitor. Otherwise, if something left from this topic, I will discuss that. Thank you.